Welcome to this video about Chimera. Chimera is an impairment emulator which allows you to emulate the impairments of real-world Ethernet networks inside your lab. In this video, I'll demonstrate Chimera's ability to limit the bandwidth of Ethernet packet flows passing through the device using the policers and shapers of the impairment pipeline. For this demonstration, I will use the Xena live demo system, which is connected to the internet and available to you so you can try it out at any time you want. If you're not familiar with the Xena live demo, I will encourage you to watch the step-by-step video guide on how to connect to the Xena live demo system. Chimera supports 5 speeds, going from 10G to 100G. For this demonstration, Chimera is configured for 25G operation and connected to a Loki traffic generator. In 25G configuration, both devices have 8 ports. In this setup, I will use the Loki traffic generator to generate a stream of Ethernet packets which will pass through Chimera, here acting as a bump in the wire, and then be looped back to Loki. We will see how Chimera can be used to control the bandwidth of the packet flow passing through. This includes looking at the different effects of the latency when using a policer at the input or a shaper at the output. At the receiving port in Loki, we will use the bandwidth measurement tools as well as internal Chimera statistics to see the effects of the impairments which are introduced by Chimera. Next, let's take a look at the Xena live demo system. This is the Valkyrie manager connected to the Xena live demo system. This system has a Chimera impairment emulator located in module number 2 and a Loki traffic generator in module number 0. If I expand the ports, I can see that both modules are configured for 25G operation and that both have 8 ports. They are directly connected as was described in the previous slide. I can further see the Chimera ports are organized in port pairs. For this demonstration, I'll be reserving the port pair on Chimera, including ports 0 and 4, and the corresponding ports on the Loki traffic generator. Further, I'll click the Used option so I can see statistics on the ports. Finally, I need to add a stream to the Loki port 0. This is done by right-clicking, adding a stream, and then configuring the stream properties. I will configure a wire speed load of 100%, and further, I will configure fixed size packages of 64 bytes. This concludes the initial setup, but before we move to the Chimera configuration, let me talk about Layer 1 versus Layer 2 bandwidth control. When an Ethernet packet is sent across a link, it consists of a DMAC, SMAC, a payload, and the final FCS. We can calculate the Layer 2 bandwidth of the link by dividing the number of L2 bytes sent by the transmission time. This will tell us about the Layer 2 information set, but it will not tell us the exact link utilization because it will depend on the Ethernet packet size. To precisely calculate the link utilization, we define the Layer 1 packet as the Layer 2 packet plus an 8-byte preamble and 12 idle bytes, knowing that the mandatory number of idle symbols will be 12 bytes over time. In short, the Layer 1 packet is defined as the Layer 2 packet plus 20 bytes. Using this definition, we can now calculate the Layer 1 bandwidth and the Layer 1 link utilization in percent. Using the Layer 1 utilization percentage, we can determine whether the link is fully utilized or if additional idle bytes are inserted between the packets. As I'll demonstrate later, Chimera and the Valkyrie traffic generators provide both Layer 1 and Layer 2 statistics for all ports, streams, and flows. With this in place, it's time to start looking at using Chimera for bandwidth control. The policer is located at the beginning of the impairment pipeline and will discard packets based on a leaky bucket algorithm. Because the policer discards non-conforming packets immediately, the policer will not change the latency or jitter of the conforming packets passing through this flow. This is different from the output shaper, as I will show you shortly. Going back to the live demo, I'll start the traffic on Loki port 0. Moving to my port counters on the global statistics, I can see that traffic is now being sent with 25G from Loki port 0, received at Chimera port 0, and likewise transmitted back from Chimera port 4 and received on Loki port 4. Looking at my stream statistics, I can see that the latency of the packets is now 7.3, which is close to the minimum latency of Chimera, which is 7.2 microseconds. Finally, looking at the Chimera statistics, I can see that all incoming packets are mapped to default flow because we're not configuring any flow filters in Chimera. At this point, we need to enable impairment at the port level. We do that by selecting the port and clicking Enable Impairments. To configure the policer, I expand the configuration window and set the parameters. We will begin with bandwidth control at layer 2 and a committed information rate at 17.5 gigabits per second. I'll configure the committed burst size to 10,000 to allow packet sizes of 10,000 bytes to pass through the policer. I'll click Start and go to my global statistics. I can now see that Chimera is limiting the layer 2 bandwidth to 17.5 gigabits per second, which is also what is received at the low-key port 4. Moving to the stream statistics, I can see that the latency of the packets is 7.3, which is close to the minimum latency of Chimera of 7.2 microseconds. Now, to illustrate bandwidth limitation at layer 1, I'll reconfigure my policer to layer 1 and set the committed information rate to 14.3 gigabits per second. I apply and I move to my statistics. At the port statistics, I can see that Chimera is correctly limiting the layer 1 bandwidth to 14.3 gigabits per second, which is also what is received at the low-key port. With this, I can turn off my impairment and move to look at the shaper. The shaper is located at the output of the Chimera impairment pipeline. Here, it will hold back packets until they're considered conforming by the leaky bucket algorithm. To hold these packets, we allocate a shaper buffer inside the impairment pipeline. Non-conforming packets are stored here. If the shaper buffer overflows, packets will be dropped. Due to this buffer, packet latency and jitter is affected by the shaper, unlike the policer discussed previously. To configure the shaper, I'll expand the shaper configuration window. Again, we'll start with bandwidth control at layer 2. I'll configure a committed information rate of 14.9 gigabits per second and a committed burst size of 10,000 bytes. Finally, I'll set the buffer size to 50,000 bytes to allow 5 max size packets in the buffer. I'll press Start and move to the global statistics. The port counters now show that Chimera is limiting the traffic to 14.9 gigabits per second, which is the same as received in the low-key end. Moving to the latency measurements, I can now see that the latency is significantly increased from 7.3 microseconds to 34.6 microseconds. This is due to the shaper buffer I explained previously. Finally, I want to illustrate bandwidth control of the shaper at layer 1. I'll reconfigure the layer and set the committed information rate to 4.9 gigabits per second. I'll apply and move to the statistics. Here I can see that Chimera is limiting the layer 1 bandwidth to 4.9 gigabits per second, which is the same as received in the low-key end. Now I can turn off my traffic and I can stop my impairments, and that's it for this demonstration. Thank you for watching.